Covalent bonds are formed when atoms share their electrons, and by sharing their electrons, that holds these molecules together. So let's take a look at two atoms of hydrogen in their neutral state. Atomic number 1, so hydrogen has one proton in its nucleus and one valence electron. Now, this is not a stable arrangement. They would each need one more electron in their outer orbital to reach a stable configuration. By sharing their electrons with each other, and thus forming hydrogen gas, H2, they achieve a sense of stability, because each of these electrons are filling their orbitals, and thus each atom feels like it has two electrons in its valence shell. And of course that is a maximum number of 2 that valence shell can hold, so each atom is stable. By sharing their electrons, they achieve stability. So let's take a look at a bigger molecule, a molecule of methane, carbon atom attached to 4 hydrogen atoms. We see carbon here, atomic number 6, with 6 electrons surrounding its protons in its neutral state. It has 2 electrons in that first orbital, and then 4 valence electrons. Thus, carbon would need an additional 4 electrons to fill that valence shell and be stable. Hydrogen, of course, just has that 1 electron surrounding its nucleus, and thus it needs 1 electron to have a stable outer ring that's stabilized just by having 2 electrons in it. So, carbon tends to form 4 bonds. It can attract hydrogen atoms, 4 hydrogen atoms, to bond with, and you see each of those hydrogen atoms are bringing one of their electrons to that orbital. And now this is a stable arrangement for all of these atoms because the carbon now feels like it has 8 electrons in its outer orbital, and each of the hydrogens feel like they have 2 electrons in their outer orbital. That orbital diagram can be replaced with a structural representation of methane. Shown here, each of those pairs of electrons that are shared being represented by a solid line. So each of those lines represents a single covalent bond, in this case between carbon and hydrogen. And we see here that we've come up with a certain way to predict how many bonds each of these atoms will form. However many electrons are needed to fill that outer valence shell, how many bonds these atoms will form. So carbon needs 4 electrons, it makes 4 bonds. Hydrogen needs 1 electron, so each of these hydrogens have only 1 bond coming out of them. So restating that simple rule there at the top, the number of valence electrons that are needed by an atom to fill an outer orbital are the number of covalent bonds it will form. So take a moment, pause the video, and answer the following questions. How many covalent bonds will each of these atoms form? Okay, so hydrogen, we've seen atomic number 1. It needs 1 electron to fill its first orbital, which can only hold 2. Thus, it will always make 1 bond. Carbon, again, as we've been showing you, the 4 electrons are in the outer orbital, and it needs 4 more to reach that stable arrangement of 8. Now, nitrogen is atomic number 7. Therefore, it has 2 electrons in the first orbital and 5 valence electrons. So to get to that stable octet, it will need 3 additional electrons, and it'll make 3 bonds. Oxygen, atomic number 8, has 2 electrons in its first orbital and 6 valence electrons in its second orbital. Thus, it needs 2 electrons to reach the octet, and it will form 2 bonds. So here's water, H2O, shown in its structural formula, and see if this makes sense with the rules we've outlined and what we've determined for each of these atoms to the left. And you see that indeed oxygen likes to make 2 bonds, and you see oxygen with 2 bonds coming out of it, and hydrogen, each of the hydrogens have only made 1 bond. Thus, each of these atoms feels like it has a stable outer arrangement of valence electrons, and we see 2 covalent bonds.